We're going to be looking at example 5 in your section 4.5 notes. We'd like to find the point P, which I already have labeled on our picture, on our curve y equals x squared. If it's any general point P, we'll just let x be the x coordinate and y is always determined by x squared. Okay, and we want to find the one that's closest to the point 18, 0. So I went ahead and labeled the distance between those 2 points is D. And we want to find the least distance between P and 18, 0. So we are going to be using the distance formula from algebra to do this. So we're definitely constrained by being on the parabola for our point P. So that's our constraint equation is y equals x squared. And our distance formula, if we plug in the 2 points that we have, we're going to have, it doesn't matter which way you subtract, so I'm going to have x minus 18, that quantity squared, subtracting our x coordinates, and then for my y coordinates, I'm going to have x squared minus 0. Okay, and I'm going to have that quantity squared. Okay, so going ahead and FOILing this out, I'm going to get the square root. I'm going to have x squared minus 36x plus 18 squared is 324. Okay, and here I am going to get a square and a square. I'm going to get x to the 4th. So that's our distance formula all about the letter x. Okay, so next up we want to take the first derivative of that. So we always get 1 over 2, okay, of that square root. Okay, now we have to make sure we take it times the derivative of the n side because of the chain rule being in play here. So the derivative of the n side, we're going to have 2x minus 36 plus 4x cubed. Okay, now the good news is all those terms do divide by 2 when I put this together. Okay, so I'm going to have the square root downstairs here. Okay, I'm going to end up with excuse me, I was dividing by 2. So I'm going to end up with just with an x and a minus 18 and then a plus 2x cubed. Okay, so this downstairs, especially if we kind of look back, is never going to be 0 because we have something that's squared on both parts of this. So our critical point comes from looking at the numerator and setting that equal to 0. That's not easy to solve algebraically, so we're going to use our graphing calculator to help us out to find the critical point. So if we go ahead and plug that numerator into our graphing calculator here. Okay, so I went ahead and put in the x, the minus 18 plus 2x cubed, and when I hit my graph button, I'm looking for the x-intercept. Okay, all right, so we should be able to see the x-intercept. The x-intercept is right here. It's x equals 2, so that's going to end up being our critical point. All right, we're going to use that to test. So I'm going to go over here to test. Okay, not really worried about interval here. This will end up being our local min or our absolute min that we want. So if we pick something and we know this part is always going to be positive, so we're really worried about the numerator. So if I pick something like 1, right, I'll have 1 minus 18 plus 2, that's negative. Okay, if I pick something like 3 and I go ahead and plug it in because of the 3 cubed, right, we'd get 27 times 2, so that's definitely going to be okay. That'll be a positive. Okay, so we know that x equals 2, okay, is the x coordinate of the parabola. Very easy to find the y coordinate because we'll square the 2. Okay, so that's the point that's closest to 18, 0 on our parabola, but it's actually asking us for the distance. So we need to plug our x and our y in to our distance formula. Okay, so if I go ahead and plug in 2, you'll get negative 16 squared. Okay, and if I go ahead and plug in for right here, right, so we get 2 squared or 4. All right, working this out, we're going to get the square root of 272 when we add those square each one and add them together. And then if we rationalize that, okay, we end up getting, or simplify rather, we get 4 root 17 as our distance. Okay, you can maybe make you feel a little bit better to see what the actual distance is. Okay, so 4 square root of 17, so it's about 16.5 units. So we can kind of put that approximation in as well, okay, since it's a distance. And that does it for example 5.